All right, welcome to tonight's lecture. So we're going to start the introduction to statics, and we'll do some introduction, quite right, and we'll also look at some basics, some of the things that you need to know for you to take this course. Yeah, and the other thing is, yeah, if you want to contact me if you have any questions or you want to know anything about how we conduct these classes, feel free to contact on these lines on the screen. Yeah, so let's quickly begin. So this is what we're going to cover in this lecture. Yeah, so we're going to look at mechanics, we'll look at basic concepts, like I said, and then we'll also look at scalars and vectors, Newton laws of motion, units of measurement. Then from there, we'll look at Newton's law of gravitational attraction. And I'm sure all these subtopics you are seeing on the screen right now, you've seen them somewhere. Yeah, you've seen them somewhere, which is just, this is just what you did in your first year physics. Yeah, so this is an introduction to statics, in other words. So whatever you did in physics, like I told you, the first time we met, I told you to say whatever you did in physics was just an introduction to everything that we're going to start doing. Yeah, so let's look at some learning objectives. Okay, so in this lecture, after this lecture, one, I'm sure some of you, or let me just say all of you, if you finish going through this slide, I'm going to send the slide to the group as well, so that you can have a look at everything that we're going to learn. So after going through this slide, one should be able to explain the mechanics, and I mean, they should be able to explain the term mechanics and statics. They should know even the difference. Then apart from that, they should also able to explain. They should also be able to explain the theory of engineering mechanics. And apart from that, to also discuss the basics, the basics concept of statics. Then they also need to at least carry out the unit conversions. Yeah. All right. So let's take a look at an introduction to statics. So what is statics? So when you say an introduction to statics, we need to know first what statics is. So statics is basically a branch of mechanics which deals with the study of conditions under which rigid bodies are at rest. Yeah, so in a static, in a state of static equilibrium. Yeah, so what this point means is that this is exactly what I told you in the last lecture which we had. I said there are actually two. It's not only statics. After statics, we also have to learn what is known as dynamics. So statics only deals with objects that are at rest, the objects that are not moving, as you can read from this statement. Yeah, so statics deals with objects that are at rest. Yeah. And then when you talk of dynamics, which is the course that you're going to take next semester, it will be talking about the bodies, the rigid bodies that are in motion. All right. So, and then when you talk about the term mechanics, so mechanics is simply just a physical science which deals with the state at rest or motion. So this one combines, let me say this one deals with both objects or bodies that are either at rest or motion or in motion, under the action of forces. So what is just or what differentiates the two statements, statics and mechanics, is simply just the fact that for mechanics would deal with everything with both an object that is at rest or the object that is in motion, provided there's a force that has been applied to the particular object, while statics will only deal with the object that is just at rest. Yeah. Okay. So let's quickly move on. Okay, so mechanics can be classified as the diagram below. Yeah, so in mechanics, we have two components that we can discuss. We have solids and fluids. So for those that are doing civil engineering and mechanical engineering, you do both. You do solids and you also do fluid mechanics. So solid mechanics is simply the things that we're going to be discussing. Yeah. And then fluid mechanics is also a course on its own. That is, I think, in third year. Yeah, it's in third year. There's fluid mechanics 1 and fluid mechanics 2. So fluid mechanics is simply just a course on its own, which is also going to be discussed in details. Then under solids, we have two components that we can discuss. We have rigid bodies and deformable bodies. And then under rigid bodies, or before we talk about rigid bodies, let's first look at the fluids. So under fluids, we also have two components that we can discuss about fluids. We have fluids that are compressible and also the fluids that are incompressible. So this is what we have there. And then we also have under rigid bodies, we can also discuss statics and also dynamics. So this is what I was simply just explaining in the previous slide. I said, when you talk about rigid bodies, when you talk about rigid bodies, these rigid bodies, they undertake two, let me say, streams. We have the first one, which is statics, and the second one is dynamics. Yeah, so under statics, we discuss objects that are at rest, and then dynamics, we're talking about objects that are moving, and this is due to a force. Yeah, so this is due to an applied force, in short. All right, so we can also discuss some basic concepts which we will need to understand. Yeah, so we can discuss some basic concepts which needs to be understood before we start, before we continue dealing with, before we start discussing statics in detail. So some of these concepts, you need to know what a space is. So when you talk about space and statics, we're simply referring to a geometric region within which a body or a particle may be located by polar coordinates or Cartesian coordinates. So space is simply, let me just say what you already know. It's simply just a region in space, yeah, where the object or a particle may be located. Yeah, so the location that we're talking about, this can be, we can use polar coordinates or Cartesian coordinates to locate this object. So let's say, for instance, if you have, if we're using, let's say, Cartesian coordinates or polar coordinates. Okay, let me just say, if you have anything, let's say you have a body here, you have something like this, you have a body. Yeah, so now the region in space, this space here that you have, and then where you can locate this object using Cartesian or polar coordinates. So you can use the X or Y plane if we want to locate this object. Yeah, so now this region where the object is or is found is the one that we're calling the space. And then the other term is the length. So length is needed to locate the position of a point in space and thereby describes the size of the physical system. Yeah, so length is simply just used to, or it's just needed to locate the position of a point in space and thereby describing the size of the physical system. So length, we know what length, we all know what length is, simply just what has been talked about here. Yeah, okay, the same length that you know is the length that we're talking about. Even the same space that you know, that's the space that we're talking about. It's just that these statements here are just used, just technical ways of describing these terms. Yeah, but otherwise there's the same space that you know is the one that we're talking about, and the same length that you know is the one that we're talking about. Yeah, so, and these terms, moreover, they can't ask you in a test or in an exam to define what space is or what length is or what is time. You'll never find these statements or these questions in an exam or in a test. you'll never find them. Statics is all about calculating. It's all about calculations. So in other ways, this is just an introduction to statics. So we are going to have, after this slide, the next slide that we're going to start discussing, that is the next time we're going to meet for statics, the next slide that we'll start discussing, we'll go in details, we'll start solving questions. Yeah, so we'll start using the concepts that we're going to learn today now to solve. Yeah, so even before we start solving, I'll always be explaining things. At least you need to understand what we're going to be solving. It's not just a matter of solving, but you need to know what you're solving and why you are solving. And you also need to know how to apply the same concepts in you also need to know how to apply the same calculation in real life situations. All right, so let's quickly move on. So we also have another term, which is just a force. So a force is simply just an effect. It's that effect which tends to cause the body to change its state of rest or uniform motion. Yeah, so a force is simply just the effect which changes the state of a body. So if the body was at rest, whatever you're going to apply this side for this body to start moving in this direction or in this direction when you apply it from this side is what we call a force. And then there's also what is known as the mass. So the mass is simply just the quantity of matter in a body. Yeah, so this is just the basic definition of mass. We all know this. Yeah, so mass is simply just the quantity of matter in any body. Yeah, so the amount of substance in any body is what we simply call the mass. Yeah. Okay, another way of defining mass, which is a bit advanced, is simply just the last part here, which is which we can say it is the measure of the inertia of the body. So the mass is also defined as the measure of inertia in a body. So this kind of a definition will be understood when you start discussing inertia. Yeah, moments of inertia. All right, so we also have other terms. But before we talk about other terms, let's look at the types of forces that we have. So we have contact forces. So when you talk about contact forces, we're talking about the forces that involves maybe two objects which are in contact. This object can either be moving in the same direction or in opposite direction, or they can all be at rest. But the force between these two objects that are in contact, we call it the friction force. Yeah, so yeah, the force that is between these two objects, we call it the contact force. And an example of these contact forces, we have the friction force. Yeah, so when you have two objects, these objects can either be moving in the same direction or in opposite direction. So we have the first object, which is object A, and object B. So these two objects can either be at rest, they can be moving in the same direction or in different direction. As long as there are two objects and they are in contact, the force that is between these two objects here, we call it the contact force. So one example of these contact forces is the friction force. Then apart from the contact force, we also have another type of force which we call the non-contact force. So non-contact forces, examples that we have are gravitational forces, and there are also other forces that are just, let me say, maybe, which force can I give an example? We have gravitational force, and which other force? We can also talk about inertia. We have a lot of forces, different forces, air resistant. Yeah, so non-contact forces, an example is the gravitational force. Yeah. So let's quickly move on. We also have we actually have a lot of terms, so I'll be going through them bit by bit, but I'll be a little bit fast. Then the other thing that you need to understand when you're talking, whenever we're going to be learning statics, the other term that we're going to be using very much is particle. So what is a particle? So a particle has mass, but has a size that can be neglected. So a particle can be any object, in short. So when you talk about a particle in statics, we're talking about any object. This can either be, this can have a defined shape or size, or its size can be neglected. Yeah, so this is what we mean when you talk about the particle in statics. So whenever you hear particle, we are talking about something that has mass, but its size can be neglected, or we can consider its size depending on the type of question that we've been given. If the dimensions of the particle has been given, then the size will not be neglected. But if the dimensions are not given, then you neglect the size, you just get the mass, its mass. Yeah. Then you also have a rigid body. So what is a rigid body? So a rigid body is a combination of a large number of particles in which all particles remain at a fixed distance from the other, both before and after applying the load. So when we talk about a rigid body, let's say if you have this body here, this is the body, this is a rigid body. So this is just a combination of particles. Remember we said a particle in statics, when you talk about a particle, we're talking about anything or any object that has mass, but its size can be neglected. So imagine we have, let's say for instance, particles in this body. So any body that contains particles, and then these particles are equidistant from each other, and yeah, these particles can be equidistant from each other, and their positions, even after adding a force this side, their position is maintained before and after adding the force this side. That object will be called a rigid body. Remember when we talked about mechanics, we had two, we had two types of solids. Remember when we talked about mechanics, we had mechanics there. This is what we had, and then we had mechanics there, and then this side we had two. Let me do this. We had something like this. Forget about this. So we had solids this side. And then apart from having solids, this side we had liquids or fluids. Let me use the word fluids. So we had fluids this side we had solids. Then under solids, this side we had a rigid body. We have rigid body this side. And then this side we had deformable bodies. So for deformable bodies, when we add or when we apply a force on this object, you discover that the particles in this object or in this body, they will change their position. Maybe this particle will move to this position, this particle will move this side, depending on where the force is being applied from. So for deformable objects, the particles tend to move in the object when the force has been applied to this body. But for rigid bodies, the particles will still maintain the same position. When you move this body, as long as it's a rigid body, this particle just translate, or if you are rotating this particle will rotate, but it will still maintain its position in that body. The position of a particle in a given object or in a given body does not change. Okay. Okay, let me not say the position, let me say the distance from each other, it does not change, but in deformable objects, the distance of the particle from, let's say if you have this particle, it's here, if you have this particle here, and then you add a force from this side, this particle, if this object is a deformable object, it will move maybe to somewhere at this point, meaning the distance that we had from this to that will change it will increase, because from here to here, maybe let's say this is 2 centimeters. As this object moves from this point to this point, you discover that the distance here will change. It's going to move to that. So meaning the distance will increase to somewhere, maybe, for instance, we have 4 centimeters this side. Yeah, so when there's a change in the distance from particles, when the force has been applied to any given body, that body is known as a deformable object. But if there is no change in the distance between these two particles, I mean between the particles of a given body when the force has been applied to it, then that given body is called a rigid body. And then apart from a rigid body, we also have what is known as concentrated force. So what is a concentrated force? So a concentrated force represents the effect of a loading which is assumed to act at a point on a body. So when you talk about the concentrated force, if you have, let's say for instance, this is an object, it can either be a deformable object or a rigid body, or it can be a deformable body or a rigid body. So when you talk about the concentrated force, this is just a force that is directed to a point on a given body. Let's say if this is a point, we want to apply a force at this point. So if we apply that force at only one point of this body, that force is known as the concentrated force. So these terms are simple and straightforward. You don't need to master them, just need to know them in case one of these terms has been used in a question. Yeah, so this is just a repetition of the page. Okay. So let's take a look at the three laws of Newton. I mean, Newton's three laws of motion. So the first law, the same laws that you learned in physics, they do not change. So the same laws as are the ones that we're also going to discuss here, and we'll also have to solve some questions under these laws. Yeah, so just put them into practice in other ways. So the first law we know to say, the first law states that the body will remain in its state of motion until, or if there is no external force acting on it, or if there is no disturbance, it will continue in its state of uniform motion. So this is what this states. So this is another version of defining the first law, which is if the resultant force acting on the particle is zero, if the resultant force acting on a particle is zero, the particle will remain at rest if originally at rest, or it will move with a constant speed in a straight line. That is, if originally it was in motion. So if the particle is at rest, as long as the resultant force that is acting on this particle is zero, the particle will remain in this same position for as long as it was originally at rest. Yeah, so what this means is that you can leave a cup in a house as long as you can leave in a cup on a table in your room, as long as there's no force that has acted on that cup in your room. You can go somewhere for years and come back, you still find the cup on the same table, on the same position, as long as there was no force that acted on that cup. Yeah, so that's what it means. And then it also means that if you have an object that is in constant speed, if that object is moving at a constant speed, as long as there's no force that has been that is acting on that, or that has been as long as there's no force that is acting acting either maybe against or that is trying to increase the speed of that given object, the object will continue in its straight line. If there's no disturbance, in short, if nothing is disturbing, if nothing has disturbed that given object or that given particle, which is at constant speed, the speed will be maintained and it will continue in its straight line motion. That's what it means. So what it means is that if you have an object that is going in this direction, it's going in this direction, as long as it's going in a straight line in this direction, as long as there's no force that has come to act on this body, either from this side or from this side, this object will continue going in a straight line. It will not turn, or it will not turn either left or right. Yeah, so that's what that means. All right, so let's quickly move on. So the other term that we have, okay, so let me just go through this. So when you talk about balanced forces, the particle at rest will have the velocity equal to 0, and the acceleration of that particle will also be equal to 0, and it will stay at rest. That's what this law means. And then the particle that is in motion, the velocity will be greater than 0, and the acceleration will be 0. It's in motion and it is at constant speed. So remember in physics what we used to say. We all know to say if the particle is moving at a constant velocity, if the particle is moving at a constant velocity, then the acceleration is always equal to 0. So as long as there is no external force acting on that particle which is at constant velocity, the particle will still remain. Will still stay. It will stay in motion, and then apart from staying in motion, to continue with the same speed and moving in a straight line, as long as there's no disturbance. All right. So let's quickly move on to the next point. So the next law, which is the second law. So for the second law, one thing you have to understand about the second law is that it's just, if you can't define it using words, you just need to know the formula. The second law is simply just force is equal to mass times acceleration. So what this states is that if the resultant force acting on a particle is not 0, so the first one talks about the particle which is either at rest. The first law, it talks about the particle which is either at rest or in motion, but the resultant force on this particle is 0. And then the second law talks about the particle that is moving, that can either be moving. Okay, let me just say the resultant force of this particle, or the resultant force acting on this particle, is not 0. In the first law, the resultant force of the which was acting on the particle was 0, but in the second law, it's not 0. So the particle will have an acceleration. The particle will have an acceleration which is proportional to the magnitude of the resultant force and in the direction of its force. So what this means is, if you have a force that is acting on, if you have a force that is acting on a given particle, so yeah, if you have a force that is acting on a given particle with the mass m, the acceleration of this particle will be proportional to the magnitude of the resultant force. Yeah, so in other words, what they mean is this: if you have this is how they formed this formula. If you have the force F, okay, this is just a formula. This is how it came about. Let me just explain it a bit. So if you have if you have an object, or let me use the word particle. So if the particle, if you have a resultant force acting, if you have a resultant force acting on a particle with its mass m, with the mass m, its acceleration is proportional, meaning it's directly proportional to the force acting, or to the magnitude of the resultant force, which is this F that you have there. And it's in the direction of this same force. That's why you are seeing this A is directly related to the force. And the constant of proportionality is called the mass, which is m. I don't know if you've gotten the point there, but what is important is for you to just know that the second law states that force is equal to mass times acceleration. That's what it means. Okay, let's quickly look at the third law. So the third law states that for every action force, there's an opposite and equal reaction force. That is the third law. Yeah, so this is another version of how you can define it. So it states that the mutual forces of action and reaction between two particles are equal in magnitude, opposite in direction, and collinear in orientation. So this is an example. If you have these two objects that are moving, yeah, so if you have these two objects that that are in contact, you have one force which is coming from this side, the other one is coming from this side. I'm coming. Let me just look at something. Okay, sorry for that inconvenience. So I'll say if you have these two particles that are in contact, as long as they all have the forces, these forces are are always opposite and equal. For every action force, in short, for every action, there's always an opposite and equal. There's always an opposite reaction force, which is equal in magnitude to its to its to the forces, in short. So what this means is that if you have, let's say, this object here, you have this object here, for instance, there's also another object there. As long as we have these objects, they have equal masses. As long as they have equal masses and they have equal forces, or they are moving towards each other, let me put it this way, with the same velocity, the forces they are going to exert on each other will be equal in magnitude. Apart from being equal in magnitude, they are going to be opposite in direction, and they are going to be collinear, meaning they are going to be in the same line. As you can see, this is the same line there. Yeah, so that's what they mean by collinear there. Anyway, these laws are just the same as what you learned in physics. So we're just going to put them in action when we start to solve some questions. All right, so yeah, so let's look at the Newton's law of gravitational attraction. So I'm going to be a bit fast because the time is counting down. We're just remaining with about 4 minutes. If it ends before I finish, then we'll have to connect again using the same link. Okay, so Newton's law of gravitation. So this one we know to say the force of gravity is given by, this is so the force of gravity is given by mass, the first mass of, if you have two objects, let me put it this way, if you have two objects, M1, and you have another object, M2, you want to find the force of attraction between these two objects. You simply have to get the distance between the center of this object and the center of this other object. When you get this distance is called R. This is the R that you have there. And then M1 and M2, you get the masses of these two objects or two particles. And then apart from that, this gravitational constant is given. So this is just the universal constant. Yeah, universal constant known as the constant of gravitation. Okay. So M1 and M2 are masses of the two particles. And then R is the distance between the centers of the particles. So remember what I said, you get the distance from their centers there, from their centers. Meaning you have to add the radius of this plus the distance there plus the radius of this other object. So the universal constant of gravitation is simply just 6.673 times 10 to the power negative 11. And then, yeah, so this is what I was just explaining. When you have two objects, then you want to get the force of attraction between these two objects. You simply get the distances from their centers. That is what you're calling R. Then you also get their masses. Then you plug them into this formula there. Okay. What if you have an object that is on a planet like Earth? How do you find the gravity or the force of attraction? You do the same, because we know to say the force of attraction or the force due to gravity is called weight. So weight is given by mass times gravity. So now I want to find what this G is. So if we're talking about Earth, we know to say, we know the radius of the Earth, it's a constant. So from this formula, we have G, we have F is equal to G, M1, M2, then everything over R squared. So this R is simply just the radius of the Earth. So you get the radius of the Earth, you put it there. Then M1, you get the mass of the Earth. It's also a constant, you can put it there. And then this G is also a constant. But of course, while there's F there, we're going to put mg. So we say this is equal to m, which is the mass of the object on Earth, and then m, this will be, this other m will be the mass of the Earth, then over the radius of the Earth. So this m and that m can cancel, can divide, and then we also multiply it by this g. So when you simplify this expression, you find that the answer that you're going to get is 9.81 meters per second squared. That's how you find, or that's how they got this figure. Okay, so this is what I was just explaining. We know the mass of the Earth is 5.97 times 10 to the power 24 kg. And then the radius of the Earth is simply just this one that you put there. So that's how they got that. And then while there's mass there, I'm going to put, where there's mass there, I'm going to put this figure there. Then G, we know I showed you the value of G, which is 6.673 times 10 to the power negative 11. That's what you put there. All right, so let's end here. Then we join using the same link. Yeah, so let's just end here. Okay, see you in the next session.